So I'm holding these two objects up in a mirror, and I'm finding when, from the perspective of the mirror, A to B and B to A shift places. I know that's not the reality of the situation, given the fact that one object is being viewed in the mirror while the other is the reflection. I just assume this because mirrors don't lie. In a mirror, given some laser beam that you can look at, it's impossible to distinguish which direction the laser beam came from. You know it reflected off the mirror, but from the perspective of inside of the mirror and outside of the mirror at the same time, it's impossible to tell the direction in which the beam traveled. That's for an infinite beam. For an infinite beam or a beam that's too far to see any source. But in reality, things are a lot closer than that when you're looking at them in a mirror. If the beam comes in this way and out that way. In the mirror, it'll look like the beam's coming in this way and out this same way. I'm looking to find expressions of the form light in, light out, and this isn't in the mirror though. This is in the mirror with it in the mirror. So, starting with the initial beam, going to another beam, a dot here for source, and then there's a mirror below that mirror takes. So I'm really running into a problem. I can't make the arrows, I can't make it chiral in all cases. But we do have the diffuse light of the sun, and that, so right here, this is the path of the photon, and this is the path of the wave. The photon actually bounces off the mirror, and we're assuming that reality is the same on both sides. So if I'm on both sides of the mirror, and I don't know I'm in the mirror, I can assume either path. I just need to remember, this only works because mu knows the state, knows the fact he has a laser. If mu didn't know he had a laser, then that observer would see, again, a wave. If they didn't know it was a laser in the mirror, it would appear to go straight through like this, and then straight through like this. And you wouldn't be able to distinguish. I got that wrong. The actual path of the particle is in a straight line, with mu knowing that there's a mirror. Disregarding the mirror, looking into the mirror, the apparent path is straight through to the wall and straight through to the wall. So wall here. Here's the path of the actual particle, and here's the resonance from the observer's perspective on which direction it's traveling. If you look in the mirror, it appears to hit the wall. Resonance or wave. It's the wavy version of what the particle's doing. It could be going this way or this way, and in this possibility right here, the truth of the matter is that those arrows get extended back for some reason. I just know they do. They get extended back to the observer. I feel like this requires a third observer. And this is in the world of solipsism, because he's going to be the only person who's actually conscious in this scenario. He stands on the side of the reel, and he sees a laser beam. Oh, my bad. He can look in the mirror and he can turn around. But this third observer cannot determine the direction of the beam for some reason. I'm assuming a perfect laser. So this observer is linked to itself in that it knows that it is in a mirror. But when he moves out of the way of the mirror, the observer's up here, or he's over here. He can't see himself in the mirror. Hate my mistakes.